Hi, thank you for joining the Oakgate Test Solutions Performance Testing and AT4 Automation scripts. This training is going to go over performance testing in general, and within performance testing, how to use the AT4 Automation tab to create your own automation scripts. If you're not familiar with how to use the Discovered Systems tab, how to attach peripherals, to configure a controller, to define traffic, you may want to go look at the basic training first and then come back to this training, as this training will assume you understand those base concepts. My name is Dave Obert. I am the Oakgate America Sales Development Manager. You can see my email on the screen. Feel free to email me if you have any questions in terms of how to use the product, how to procure the product, any of those types of questions. Please feel free to send me an email. Why are we talking about performance? Well, because you don't want to be this particular drive. This drive, as you can see, had a significant spike in read latency. And the reason this drive had a spike in read latency was it did not handle large trims very well. And when those trims hit the drive, it caused a huge spike. So while you will certainly want to do your standard performance tests, you also will want to validate your performance under instances of large trims, under instances of admin commands, under instances of MI commands, just to ensure that your drive maintains the type of performance no matter the conditions. And we're going to show you today how to do that. In this class, we're going to cover push-button performance tests such as SNIA and OCP 1.0. As we said, we're also going to create a performance test in the Automation tab. We'll go over the actions and attributes of prefill, 3 ways to create loops, defining tests, we'll talk about MI, and then we'll show about reviewing your results, creating automated graphs, reviewing the .html file, getting smart data, and your auto-generated performance report. That will all be in this training today. If you're not familiar with SNIA, SNIA is the Storage Networking Industry Association. It is a not-for-profit global organization that leads the storage industry in developing and promoting vendor-neutral architectures, standards, and educational services that facilitate the efficient management, movement, and security of information. And their web address is here on the screen. They do have defined performance standards. Those are included for free within the Oakgate package. But if you want to go to SNIA and look at those standards, you can. SNIA is a great resource in terms of storage information and training. We also will talk about OCP, or the Open Compute Project, and this specification has a range of components to it, one of which is around performance. You will be able, with Oakgate, to utilize an OCP conformance test and to ensure that your drive meets the OCP performance standards. So let's talk about our push-button performance tests first. The first one is the SNIA 2.0 tab that you see here in the Oakgate software. You can bring it up by just clicking on this little easel type of thing, and it will come up. You need to have the namespace highlighted, and when you do, if you click on a box and then highlight that test, it will give you the information in terms of the test that you can configure. And you can also configure the report configurations where you want the information in the test and then get a test log. So this has, as you can see, a range of tests that you can run. These tests do take a significant amount of time to process the whole test, so be aware of that. But if you do want to just run a SNIA test and get your results back, this is certainly an easy way to go ahead and do that. In terms of OCP, to run OCP, you'll come to our directed tests, and you will see an OCP section. And within this, you will go ahead and highlight it and then pick the set of OCP tests that you want to run. The performance piece of it will most likely also require a Python framework or Python implementation. And so you'll want to make sure you get that also as you move forward with OCP. So both of those ways are fairly push button ways to do a performance test. And now we're going to move into the third way, which is creating your own performance test within the automation script. The first thing we're going to do is give ourselves a little bit more room to see what's going on. And I'm going to drag this down a little bit here for a second, and we're going to click this box and this box to open up the windows here, so that as we're defining our test, we're able to better see what we're doing. And I will then drag this back so it fills up the screen, move forward. The first thing we're going to do is define or provide a name for our test, so when we come back to use it later, we'll know exactly what it is we are working with. And so we're going to call this performance with MI, and we'll give it a description. So again, when we come back later, we'll be able to know what exactly this test does. And we'll say this test compares a baseline performance with performance while running MI. The next thing we're going to look at is, do we want to auto-associate all testable units? If we're doing this in a Python script, you probably want to check that box. In this video, I'm going to show you how to drag and drop things, so we won't do that. But again, for Python, you'll want to do that. And then, do you want to generate a performance report automatically? We do. We want to see read latency, write latency, total latency. Those will be histograms. We also will come down here and do read bandwidth, write bandwidth, total bandwidth. And you can see there's a wide range of things that I can do charts against. I can do power, I can do voltage, I can do temperature if I have a oven, I can do IOPS, latency versus time. So we have a wide range of choices. For the first test set is going to be our pre-fill test set. So we're going to call this performance pre-fill, because it will be a little bit different than what we would do for pre-fill if we were doing data validation, which you may have seen earlier. And within this, the first thing we're going to do is we're going to add an action that is an NVMe format. And within this format, I can go ahead and set it with the format type, whether I want protection, diffdix, secure erase, all those kinds of things can be set as part of the formatting. It does ask if we want to use all available unit paths. Again, we will manually do that, and we'll do that by associating the namespace with unit path 0. So that's NVMe format. We're then going to come back and add a second action, which is generic disk prefill. The first thing we're going to do with disk prefill is go ahead and say, do we again want to use all available unit paths or do it manually? And we're doing it manually. And then we want to set the prefill settings. So there's 3 different ways you can do disk prefill. You can do it by a percentage, which we're going to do. We're going to say 200%. Oakgate will use whatever it hits first. So I'm going to add a couple zeros on max fill time, so it doesn't hit that for the disk prefill percentage. And then the other way that you can do come out of prefill is by using steady state, if you want to use that. Once we've set the prefill we want to use, now we're going to come back to our unit path and we're going to start to define what we want. So the first thing we want is our Q depth to be 16. And then we're going to go to the generated traffic. Now, I did this on purpose because you notice it just shows I/O traffic. What this is telling me, I currently have this set up for block. The automation tab does not know what you're connected to, so I can set it for any protocol I want, and I want to go in and convert protocol, convert to NVMe, and it will then set it up so now you see it's an NVMe type of environment. I can also go to my preferences, and in my preferences tell it what I'm going to do normally and what my default protocol is. And in this case, I'll set my default protocol at NVMe. So when I start it up the next time, it will automatically be at NVMe. Preferences is over on the left, and it has this little icon on it. So now that I've set it for NVMe, I'm going to say, okay, I want I/O traffic, of course. The other thing I'm going to make sure I do here is check this on sequential I/O pattern policy. This will ensure as I come to the edge of the namespace, if I'm using 128K sequential writes and the hole at the edge of the namespace is smaller than 128, this will ensure that it truncates the I/O so it can fit into whatever that little hole size is at the end of the namespace. Once I've done that, I can come in and define what my I/O is going to be for a prefill. Obviously, we're going to do 100% writes. We'll go ahead and lock that in. I want 128K I/Os, both as my max and my min. And as I hit that, you'll notice it sets my step size. We're doing block aligned, sequential, and in this case we're going to, as our base, do the embedded LBA plus index. Often large hyperscalers will want you to do a prefill on top of that. That is not just a pure same size sequential prefill. So we'll follow their model and come back in and again set up a prefill. We'll do it again 200%. We'll go 3600 and we'll come to our unit path, and here we're again going to say we want 16 fixed. And we don't have to worry about sequential I/O because we're not doing sequential I/O in this case. What we are going to do is writes, and we're going to make them random. So those writes will be between a 512K packet and a 128K packet. So we'll put 128K there with a step size. I/O alignment will still be block. We're going to make this 100% random. And because we want the pattern to be random also, we're going to go ahead and do everything but embedded LBA. That will put a random mix of patterns with a random set of sizes across my drive in a random I/O pattern model, not sequential. And so that completes my prefill and gets me ready to then go ahead and add my test. So to add the test set, I'm going to come back and add a new test set. And I'm going to give this a name, which is going to be performance test. And it would be good to spell correctly. And this is where I'm going to do my first way to do a loop. And the way I'm going to do a loop is by adding initial conditions. Performance tests can often be sensitive to what your I/O alignment is. Am I block aligned or am I 4K aligned? So we're going to do an I/O alignment with block. And you see that here. And then we're going to add a second initial condition. And that's going to be an I/O alignment with 4K. Now I have two different I/O alignments, so this will function as a loop. It will go through this test set with the I/O alignment as block, and then it will circle back and go through the test set again with the I/O alignment as 4K. So that's the first way to do a loop. The second way is I can come into my performance test and go ahead and add a loop. And in this case, I'm going to add a loop. So we'll go to add loop Q depth and come down to this. And now I can go ahead and specify the Q depths that I want. And in this case, I'm going to do 4, 8, 16, 32, 64, and 128. Remember, one key thing on Q depths is whatever Q depth I have, my Q size has to be 1 greater. So when I set my Q size, I set it at 129 so that I could run a Q depth of 128 in this particular test. Now I may want to have a sub loop here, and to do that I'm going to take my sub loop and make it I/O size. And notice when I do that, I create the loop with the upper loop highlighted so that the next loop is indented. If these are in parallel alignment, then you will have a problem. You need them to be indented, as you see here. And I can go in here and go ahead and now set my I/O sizes that I want to do, and I'll edit this and take out a number of different I/O sizes. Do 16K, let's do 32, 64, 128, and 256. Some drives don't handle larger I/O sizes. You'll want to make sure that you're aware of what your particular drive can handle or not on an I/O size. If you don't know, you can always go to the configuration tab and it will tell you what the particular drive can support. So that's the I/O size. Next thing we're going to do is we're going to do a loop the third way, which is adding 2 tests in a line. So I'm going to add 1 test, and then I can come back here and add a second test. This first test, it's always good to name your tests, so when I go ahead and run my graphing, I know what I'm looking at. So we're going to call this I/O test. And this will be our baseline test with no MI. And you set your time, you set your test warm-up time, which we're going to make it 1 second, and then we're going to run the test for 20 seconds. If you're doing this on your own, you may want to run it for a longer period of time than 20 seconds. For our case, we're going to leave it at 20 seconds. We're going to, after each iteration, and as you look down here, we have the option of using all available unit paths, which again you would want to do if you were doing automation. In our case, we don't. Having defined the test, we're going to come into the unit path and set our information. Now, anything that we put at the higher level is not going to be used here. It will get overridden. So the alignment, the Q depth, the IO size all get overridden. So I don't need to worry about Q depth. I'm not worried about anything else on this particular tab. You want to make sure when you're running performance, you do not have data validation checked, as that will slow you down. Under generated traffic, if I'm doing a Gen 4 drive, I may want to consider using performance mode. If I do performance mode, then it has to be random. There are a couple other things that you would want to look at with performance mode, and I recommend you go through that in the manual, but that is an option if I'm doing a Gen 4 type of drive. For our iProfile here, we're going to do a mix of read and writes, so we can go ahead and look at both. Our IO alignment is not going to matter, nor will our IO size matter, because we've set both of those above. So those will get overridden. We did not set traffic pattern, and we're going to want this to be random, 100%. And on data pattern mix, again, we do not want the embedded LBA plus index. This does add overhead to what's being done on the drive. So you want to take this off and not use this if you're doing any kind of performance testing. So that is pretty much everything that we're doing from that standpoint. So now we're going to come to our next test, which is our IO test with MI. And in this case, what we want to do is we're going to run the NVMe stuff on unit path 0, and we're going to take unit path 1 and bring it over here and drag and drop it like you just saw, and unit path 1 is going to be where our MI stuff resides. When I do this, one of the things I want to do is come back here, and again I want to collect smart data after each iteration. And I want to say I need to make unit path exerciser configurations unique. And the reason I'm going to do that is I'm going to come in here and I'm going to convert the protocol to MI. So now this will be an MI protocol, and this one will be an NVMe protocol. I can save myself some time, and I can copy this exerciser configuration. I can come here and paste the exerciser configuration. And now this has all the stuff that I put in earlier, and so I don't have to replicate it, and I have the exact match of what I did previously. For the MI one, I'm going to come into this and set up my MI commands. And in this case, we're going to do 100% MI. We will go ahead and lock that. And we want to do 50% of the get state. So we're going to come down here and do 50% get state and lock that in. And we want 50% of get health status. So we'll lock that. And that will go ahead and send those two commands across the MI port to the drive while it is simultaneously running NVMe traffic. Before we can actually run anything, I'm going to bring back my namespaces, and we have to go in and set our namespace, which we actually want in unit path 0, and we're going to take our MI unit and put that in unit path 1. So this will anything that says unit path 0 will run against what's in unit path 0. And down here, which says unit path 1, that will run in unit path 1. The next step we want to do is we are going to define our charts. I'm not going to define all the charts for time purposes, but I will show you how to define one. So we're going to do a new graph, and we're going to go ahead and call this graph, actually we'll name it after we've defined it, and we're going to use a test set or a loop. We're going to choose, and you choose the bottom loop when you have multiple tests you want to run. If you're running a single test, you would just choose the test, but if you're running a group of tests, you'll choose the bottom loop. So we're going to choose that, and I am going to close that up so you can see what I'm doing better here. And for the left axis, we want read bandwidth. For the right axis, we want read latency. And these will be linear. For the x-axis, we're going to do this by I/O size. And we're going to set this scale at logarithmic base 2. And then for the series, we want to compare the tests. So we're going to do this with tests. Now, these become our constants. So it will be block aligned, and it will be QDepth 4. So with our constants in mind, we're going to come back and say block aligned QDepth 4. You'll want to define your graphs before you get started or while you're getting started. And these are the graphs that will show up in the automatically generated performance document that we talked about earlier. Once that is all set, we've got our unit paths associated, we have our performance graphs, we can go ahead and start our tests. In this case, I'm going to change the name here because I actually have this already set up so I can show it to you. And I don't want it to overwrite. So I'm going to go ahead and now start it. And you can see that it's starting against the unit paths that I specified. And when I come here, it will start graphing my data. Okay, so here is our completed test that has come up with the graphs already defined. Couple things on these graphs. You will notice it has all the unit paths graphed, which I may not want, because if I'm doing a compare from a performance standpoint, let me go ahead and expand this chart. You can see I have this bandwidth line that's down here, but that's actually down there because it's accounting for the MI, and in this case I don't want that. So I'm going to not expand it, and I'm going to say I don't want this unit path, and then render my graph. And now I have an accurate representation of both bandwidth and latency. Now if I just want to compare the bandwidth first, I can click here and get rid of the right side axis, latency, and see how those compare. And I can see that this is pretty much right on top. I can then bring and look at my latency and take out bandwidth if I want. And again, you can see the latency for this drive, it actually does a pretty good job of laying it right on top. If you want the automatic performance test, you need to unclick the unit path in the beginning prior to the end, or if you forgot to do that, you can come back, unclick it at the end of your test, come back to the beginning, and then tell it at this point to go to File and Generate Performance Report. So either of those workarounds will work for you if you forgot to change the setting and went ahead and graphed it and got both unit pass, and you really only wanted one. The other thing you can do is click on this, and this will give me read IOPS versus time. Or if I want something different, again, I can go back and reset those and take a look at what I got in that particular tab. So, and I'm going to go back to my automation tab on my graph definition. I may, instead of latency versus time on those secondary graphs, I may want, or IOPS versus time, I may just want read latency. And maybe I want those read latencies at 5, 6, 7, something along those lines. Then I can come back again, render my graph. When I go ahead and click on that, now I have a histogram that's going to show me what my read latencies are, and it will give me my different nines worth of data. And again, this will give me all this data. So you can create these, tell it to create a performance chart. You can do these up front. Either way, you can then set your charts and then create a performance report that will have the charts that you want as part of that. The other way to get results is you're going to view your HTML results. This is the HTML tab. And you can see here that, let me pull this in. This gives me the HTML data, and I can go ahead and drill down into my test and be able to get all the results for a particular test. So you can see the different performance tests and go into the I/O test. And again, for each test, you're going to have all the different I/O tests that were run, and I can drill down into these I/O tests and be able to get what's the data. I can get what was the random seed associated with that if I want to replicate it. I can click on the CSV log, be able to see all the different information on it. So all that information is available in the HTML file. I also have the ability to pull up the performance report. And so here's the performance report that is generated. And again, I can generate it at the end by going to File and hitting Performance Report, or just checking the box in the beginning. It gives me my charts that I created, and then it gives me a grid here that provides me the latency. And you can see here is my I/O size and the different combinations for what I did, both in terms of latency and bandwidth. It gives me all the different options across those, both for block, and the second one obviously is my 4K. Again, this is my next chart that I created, and again gives the different I/O sizes, the latency, the bandwidth, and you can come in and again pull up the charts that you saw earlier. And as an example, this one was pulled up, created. Or you can also come into here and pull up the data that will also pull up what you want. And you can see here, this gives me the I/O data that is there in terms of the IOs and the time with those IOs. If I wanted latency or other things, it would again pull those up. So whatever I define will get pulled up and get embedded as links in this particular test. So that is it for performance in terms of how to create charts, how to get the data. You can then pull the data, create presentations, or send the report to somebody as necessary. You can go ahead and reload if, for whatever reason, you want to reload something. So you can either save it or go to Load Automation Suite, and that's exactly what I did with this one, is load, and then here I have the same test. Hopefully this was useful for you in terms of how to do both the automation tab, how to do charts, do your associations, and be able to configure and define your test.